Picture this, you're scrolling through old photos and suddenly you see someone holding a smartphone in a picture from the 1940s. Or you hear about a man who claimed he traveled from the year 2036 to warn us about the future. Wild conspiracy? Maybe. But here's the question, could there actually be truth to time travel? Today, we're diving into one of the most mind-bending ideas in all of science. Could time travel exist? And the answers will shock you because scientists have already proven that time doesn't work the way you think it does. Part 1. What actually is time travel? When most people think of time travel, they picture science fiction. A shiny machine, a push of a button, and suddenly you're in the age of the dinosaurs. But scientifically, time travel doesn't have to be that flashy. It simply means moving through time at a different rate than everyone else. And here's the crazy part, you're already doing it. Right now, this second, you are traveling through time. 1 second per second, straight into the future. The real question is, can we bend the rules to move faster, slower, or even backwards? Part 2, Einstein's shocking discovery. To find the answer, we need to rewind to 1905. That's when Albert Einstein shook the world with his theory of relativity. He showed that time is not a rigid, universal clock. Instead, it's flexible. It stretches and warps depending on your speed and the pull of gravity. Think about it like this. If space is like a giant trampoline, then time is stitched right into it. Put something heavy, like a planet, on the trampoline, and it bends. That bend doesn't just curve space, it curves time as well. Here's where it gets wild. If you move really fast, close to the speed of light, time for you slows down compared to everyone else. This isn't just theory, it's been tested, proven, and measured. Part 3, the proof. We've already done it. In the 1970s, scientists ran the Herschel-Keating experiment. They took 2 super-precise atomic clocks, set them to the exact same time, and put one on an airplane while the other stayed on the ground. After circling the globe, the flying clock had ticked just a little bit slower than the one left on Earth. Time itself had bent, and astronauts proved this too. Gennady Padalka, a Russian cosmonaut who spent more time in space than anyone else, 879 days, is about 0.02 seconds younger than the rest of us because of time dilation. That means he literally experienced less time than people on Earth. He time traveled into the future, just a tiny bit. So here's the truth. Time travel into the future isn't science fiction. It's real. It's already happening. The only limit is how much we can scale it up. Part 4. Time travel to the future, the speed of light. Here's where it gets mind-blowing. Let's say you board a spaceship that can travel close to the speed of light. For you, 1 year passes, but when you return to Earth, maybe 50, 100, or even 1,000 years have gone by. This isn't fantasy. This is what Einstein's math demands. It's called time dilation. The faster you go, the slower your clock runs compared to everyone else's. At the speed of light, your time could stand still entirely. If humans could ever build such a ship, you could leave Earth today, take a short trip, and return to find the world far, far into the future. Futuristic? Absolutely. Impossible? Not at all. It's already written into the fabric of reality. Part 5, the big question, can we go backwards? But going forward is only half the story. What about traveling back? Could you really go visit the dinosaurs or meet your younger self? This is where science gets complicated. Some solutions to Einstein's equations suggest that time loops are possible. Imagine bending space-time so much that it curves back on itself. In theory, that could allow you to step into your past. One of the most popular ideas, wormholes. These are shortcuts through space-time. tunnels connecting two distant points. If one end of a wormhole was accelerated to near light speeds and then brought back, the two ends could be in different times. Walk in one side, and you might walk out years earlier or centuries later. Part 6. The challenges of wormholes. There's just one small problem. Wormholes are ridiculously unstable. If they even exist, they'd collapse instantly before anything could pass through them. To keep one open, you'd need something called exotic matter, a form of matter with negative energy. And while negative energy has been observed in tiny quantum effects, we're nowhere near harnessing enough to hold a wormhole open. But here's the twist. Kip Thorne, a physicist who literally helped design the science behind the movie Interstellar, has written detailed papers on how a wormhole time machine might actually. He proved that, at least mathematically, it's not impossible. Part 7. The paradox problem. Even if we could build one, traveling backwards creates a huge headache. Paradoxes. Take the grandfather paradox. You go back in time and stop your grandparents from meeting. If they never meet, you're never born. But if you're never born, who went back in time to stop them? It's a loop that doesn't make sense. And then there's the bootstrap paradox. Imagine you go back in time and hand Shakespeare a copy of Romeo and Juliet. He publishes it, becomes famous. But you only knew about the play because you read it in school. Who actually wrote it? No one. The knowledge just exists in an endless loop. These paradoxes force scientists to wonder. Maybe the universe has rules we don't yet understand. Maybe paradoxes are impossible. Or maybe, and this is even stranger, the universe splits into multiple timelines every time you change the past. That's the idea behind the multiverse. Part 8. Why don't we see time travelers? Narrator. Here's the obvious question. If time travel to the past is possible, where are all the time travelers? Why hasn't someone from the year 4000 shown up to tell us what happens? Some scientists argue it's because you can only travel back to the moment the time machine was created. Meaning, if we built one tomorrow, people from the future could only come back to tomorrow, not before. Others suggest time travel may be happening right now, but in ways we can't detect. Or maybe the rules of the universe forbid travelers from changing anything important, which is why we never notice them. Part 9. Time travel experiments you've never heard of. Beyond relativity, scientists are also looking at time in the strange world of quantum physics. In 2014, researchers claimed they simulated a particle moving backwards through time inside a quantum computer. It wasn't a DeLorean, but it was a hint that time might be more flexible than we think. Another fascinating idea, the cosmic strings theory. These are hypothetical cracks in space-time left over from the early universe. If two of them passed by each other, they might create closed loops in time. In other words, natural time machines. Part 10. The verdict. So, could time travel exist? Here's what we know. Traveling into the future is absolutely possible. Einstein's math proves it, experiments confirm it, and astronauts experience it. The only limit is our technology. Traveling into the past, the equations say maybe, but paradoxes, instability, and the lack of exotic matter keep it out of reach, at least for now. Right now, time travel is a door that's cracked open. We know it's not locked, but stepping through it, that's the challenge. Outro, hook, to next video. But let me leave you with this. If time travel is possible, maybe we've already met time travelers without knowing it. Could strange events in history, inventions that appeared too early, mysteries we can't explain, actually be clues? That's a story for another video. Thanks for watching. If this journey through time bent your brain, hit like and subscribe for more science that changes the way you see reality. And tell me in the comments, if you had one chance to time travel, would you go to the future or the past?